All right, the lecture for the week, Chapter 4, the first part of Chapter 4. Now remember, we're going to split Chapter 4 into two parts because it covers networking and cloud computing. It's actually covering networks, internet, web, cloud. This week, we're going to try to do a little bit of networking and start introducing the internet. And then next week we'll finish up on how the web works and a lot of the specifics and cloud computing. So let's talk about networking. A lot to cover, considering we do this in about probably a 4-class period to cover all the networking stuff. So you'll have the definitions and the terms in the Quizlet account. So let's go. Okay, what is a computer network? Basically, it is communications media, devices, of course, and the software to make these two devices communicate to each other, to be able to send data back and forth. You can hear the term network nodes or network nodes. All they are is computers, devices, physical devices that make up a network. Of course, what do we use networks for? Pretty much to share anything that's information, whether it's, we can share hardware, software, programs, databases, videos, everything that you've done using your phone and your PC. Now, network is laid up in probably two different ways. It's called a network topology, and basically a topology is just a structure. And there's two structures in networks. There's a physical topology. How is all the devices connected, hardwired together? And then second, there's a logical topology. How does the data flow from PC1 to PC2? We're probably just going to limit a lot of it to just the physical layers. And there's three major physical topologies. There's a star network, a bus network, and a mesh network. The star network pretty much has a central hub with everybody connected to it, and everything flows through that hub. So if PC1's connecting to PC2, it's got to go through the hub. If for some reason that hub fails, guess what? Nobody talks to anybody. So even though it is simple to put together, it has its risks. The next one is a bus network, and basically everything fits through one common cable. Of course, now what happens here? If this cable breaks here, these two pieces probably can talk, but it can't communicate with the rest. So it does have a potential failure if that major cable breaks. What we see most networks is what they call a mesh network, where there are multiple access points to different devices. You hear the term, there'll be two terms. There'll be a full mesh where everything is connected to everything else, so you're guaranteed to get access to somebody. There's always a route, but it's very expensive because to connect everything together, just tons of cable, which most companies won't do. But we will design what we call a partial network, a partial mesh network, and that allows multiple flows. And what you've probably seen here is a little bit of a partial. You're seeing a lot of you don't see a direct one-to-one correlation on this screen, but you can probably get to every PC, but you may have to go through other devices. So there is no direct one-to-one connection. So now there are different network types. So those are the physical topologies. Now, what kind of types of networks are there? Well, there's a personal area network, a PAN. And basically that's connecting things that just apply to one person. Maybe between your phone and your car, if your car has a Bluetooth connection to be able to let you talk over it. Or if you've got a wireless headset connecting to your phone. That is an example of a personal network. Local area network is what we're mostly used for offices and homes. The school's got a local area network. Metropolitan area network, it pretty much covers a city or a campus. So it's a larger geographic area. As you can tell, these network types are all geography specific. So from personal to local, which is a small area, to metropolitan area, to a city-wide area, to a wide area network within TARC's, countries, worlds. So they're very specific. Now, what a wide area network usually consists of is you as a consumer buys the physical equipment. Some companies will allow you to lease it, but in most cases you'll buy it, and what you do is they'll run their facilities, their cables up to your equipment to what they call a demarcation point. Think of it as the cable company comes to your house and you've got a box on the outside that they connect to, and they own from that house out. What's inside your house, that's your responsibility. So the computer equipment's owned by you. And then the data communications equipment that it takes to link back to the rest of their network, they own. Now, keep in mind, wide area network, it may cross country borders based on the size of the company you've got. Now, client servers, right now we use a lot of that today. I mean, when you're logging onto your PC, when you're checking your web mail, when you're checking Facebook, all of that is you make a request, somebody else is serving you, client-server model. Now, the client is basically just a computer that sends messages and receives messages, and the database, the server, is what actually does the work. Now, how much data can I get through a particular media that connects networks or PCs together? There's two major terms. One is the channel bandwidth. So it's what's the rate at which I can actually send data? How fast can I run? So it's usually measured in bits per second. And then you got broadband communications, and that's a relative term. But it just means that you got large telecommunication companies that can transmit data very quickly. Now, there are different types of media, physical media. There is they call it guided, but I like to call it wired or wireless. Wired is you've got a cable. You look at your PC, you're plugged in, especially at school, you're plugged into your PC's got a cable running back to some other equipment on campus. Your house probably has a combination of both of these. You got from your cable company, your internet service provider back to their cable modem. That's what connects into your house. And then you broadcast wirelessly through the house. So the three major topics of this guided or this wired is, one is twisted pair. And that's basically just copper wire twisted. And it has about its speed's getting faster, but it's got a distance limitation of about 300 feet. Coax, your cable TV has one of those. And you've seen it. They're really stiff cables with a very thick copper core, conductor. And then you got fiber optic, made with hair-thin strands of glass that they will beam light through to be able to, it's very fast, very secure, very expensive. But we're seeing more and more of it. Now, different types of technologies, different types of frequencies, as you said, is one is radio frequency range. And mobile users, we use a lot of that. Your microwave, you've seen microwave towers. As where we go through, microwave is a point-to-point network, high volume data. And then you got the infrared frequency range, and it allows me to move devices. You've got an infrared probably on your remote at your recliner and to the TV, infrared technology. So those are the three major types that are used. Now, there are a few other media. You got the near field communication. You ever play with your credit card and you just kind of wave it past, or you take your phone out and you flash it across the sensor? Near field communication. Very short distance between that and the sensor. Bluetooth, wireless communication, but we use it for cell phones. Shorter distances, less traffic on it, but most of us use it for our headsets, communication to our cars. Wi-Fi, even though it's got a brand name, it's that name Wi-Fi, even though we look at it, probably use that term more than a local area network. But what you got is it's owned by the Wi-Fi Alliance, a group of major corporations that says we're going to dictate what equipment works together. The standards for wireless communications are set by IEEE. Here are 802.11 is the major standard, but then there's subcategories, A through AC, more than that. And basically all they are distances as they get faster and faster and faster, there's new standards coming out. So just keep in mind, IEEE set the standard, 802.11 handles wireless and networking standards. Microwave comes in basically two forms. One is point-to-point landline, and then you get satellite communications. And then you got two of those. Geostationary, which means I've got a satellite that's sitting up at 22,000 miles above the Earth, and so it kind of looks like the satellite is not moving at all. So you always have connectivity. And then a low Earth orbit. Iridium uses that to have its communication. A little bit faster communication, less delay. So historically, communications here, they've put in, right now we're running this 4G, fourth generation, first generation, second, third. And basically all it is they found ways to speed up as time goes on. Right now we're kind of in this 4G long-term evolution phase, LTE, and it's just a standard to handle, the standard to go packet switching. Let me go smaller packets, break your conversation into smaller pieces and find multiple ways of getting those pieces sent from destination to destination. 5G expectations, there's no official standard yet, but definitely expect high transmission, low power consumption, so you get longer battery life, more reliability, more structure, more security. You'll probably see some trials starting, well, they say by 2017, and there was probably some initial trials, but remember, there's no standard, so the major telephone companies haven't come to an agreement yet as to what this is going to be. Some of the common devices, I'll let you go through these, but just understand basically what they may be. You may see it on the test. Now, how do I handle software? There's basically a couple of different ways. There's a network operating system, which says it's the system software that controls computer systems. You use operating systems, Mac OS, you've used Windows. But if I'm in a network base, I'm going to use Linux, Unix, Windows Server to manage network devices. Now, network management software says, now that I got a network, I need to protect the data that's being sent back and forth, make sure to modify it, to make sure it's not being downloaded, illegally, that it detects if there's somebody trying to break in, network problems, make sure it's up. And there's a couple of different ways. There's a mobile device software, which is, hey, I'm troubleshooting mobile devices. And the other one is, the next trend is software-defined networking. So instead of having a network engineer having to be at a physical device and defining it and engineering it and creating it, they're allowing it to be done over software. So just an idea, rough idea. The internet, a little bit of history there. Basically, it was created in ARPANET 1969. IP protocol is the one of the protocols set of rules that allows users to communicate. And I'm running out of time here, so take a look at the rest of how the internet works. You got IP addressing,